Sanu. Well, that's the way we say hello in Nepal. Hello children, how are you people doing? I'm Saurabh Kumar Dutt and I'm here to teach you people a little bit about irrational numbers. Now children, in this lecture we are going to look up how to represent irrational numbers in the exponential form, in the decimal form. Further, we'll also be looking up the simplification of binomial irrational numbers if they are in the denominator by the rationalization concept. Then we will also be looking up a complicated question and get to its simple answer. But children, before we get started, let us quickly make this environment to be a little electric so that you are really interested in studying this topic. So for that, let us quickly imagine that we are at this place to study this topic. This is Sagarmatha National Park, Solukhumbu, Nepal. It is 9,334 feet above sea level, an upper catchment of Dutt, Kosi and both Kosi rivers. It is a place which is a paradise for nature lovers, as here you get to spot 1,000 floral species. Beware, if the red panda, the snow leopard or the Himalayan wolf spots you, then you will become theirs. But before that, make sure to have Jerry, the famous delicacy of Nepal, and also tell all the people of Nepal, Sanu. In this note children, we are again going to say Sanu, but at this time it is to irrational numbers. So here children, we will be looking up all those things that I just discussed, and after getting an idea we will get to a complicated sum. So here children, now discussing the few concepts. Whenever you talk about an irrational number, it is actually one such number whose index or exponent is a rational number, which will remain to be a fractional one. For that matter, let us quickly have an idea. If say you talk about 2, which is raised to the power 1 upon 4. So this is an irrational number because its index or its power or its exponent will remain to be a fraction, right? Now, if we talk about representing this in the normal form, then we write this as 2 and then we make the square root sign, and in this space we write 4. However, if this is just the square root, then you don't require to write 2 because that is from where we start, right? So if say we talk about another number, say which say can be some 3 which is raised to the power some other fraction, let's say 1 upon 33, right? So again we will be able to write this as the number 3 written within the root sign, and in this space we will write 33. So this will give us the 33rd root of 3, and this is an irrational number. Now we will talk about some other numbers which can be irrational. For that matter, let us quickly consider that we have a number which say is 413, right, and whose power say is 2 upon 53. So here also we get to see that if we talk about the exponent of this number, then it is a fraction, that is, it cannot be simplified. So if it would have been a number like 8 upon 4, obviously it would have got simplified to 2, which is a number that is an integer. So if the exponent is a fraction which cannot be converted to an integer, then the result that you will get will be an irrational number. Now children, like I told you, to write this number say in the earlier form, right, we can write it as 413, which will stay within the root sign, and since we are finding out the 53rd root, so 53 is going to be written here, and since the whole power is 2, so obviously we can write the whole square of this. Just try and understand why this was done. Up to here I'm sure you are clear that if say we talk about this number, we can write this as 413 whole raised to the power 1 upon 53, then obviously like earlier you would have written it like this. But since here the numerator is 2, so obviously this can mean that the whole power must have been 2, because if you talk about some a raised to the power m, which is whole raised to the power n, then that becomes equal to a raised to the power m into n. So these are all the ways by means of which you can represent irrational numbers if they have fractional powers, right? Now children, all of this I will quickly discuss. If you talk about an irrational number, it's actually one such number whose base can be any real number, but if you talk about its index or its power, its exponent, then it will be a fraction such that that fraction cannot be converted to an integer. So 1 upon 4 is a fraction, right? Similarly, if we talk about 1 upon 33, it's another fraction. And then if we talk about 2 upon 53, that's another fraction which cannot be simplified. So a number which has such a fractional power will always be said to be an irrational number. Now, how to represent it in the normal form that we use? If you normally talk about root 3, you just write it something like this, right? So root 3 is just this, which obviously means that this is 3 whose power is 1 upon 2. But if say we talk about a number like 2 raised to the power of 1 upon 4, so whatever is the denominator, that is written in this space, and whosoever's root you're finding out, that is written inside, right? So this says that this is actually the fourth root of 2. Right? Now if we have a number like 3 which is raised to the power 1 upon 33, then this is actually the 33rd root of 3, and again it is going to be written just like we write square roots, but in this space we will be writing 33, which is the denominator, and of whatever numbers we are finding out that 33rd root, that number is going to be written within this sign, right? Now children, I gave you a little complicated example. If say we have something like 413, and if say we are talking about its exponent to be another fraction which is 2 upon 53, which cannot be simplified to an integer, right? Then how do you write it? Now if you talk about 413 which is raised to the power 1 upon 53, and if you make its whole power to be 2, obviously it's going to become 413 raised to the power 2 upon 53, because you know this, that a raised to the power m whole raised to the power n will become a raised to the power m into n. As such, 2 and 1 upon 53 will get multiplied. Now how do we write it in this form? So obviously you can easily write this, that is within the root sign you will write 413, and outside in this valley-like space you will write 53. But because the numerator is 2, so obviously you also require to square this, and thus the whole power of this is to be written as 2. So this is how children we can write the irrational numbers in the exponential form and in the normal form that you write. Now whenever you talk about irrational numbers, they are actually those decimal numbers which are non-terminating and non-repeating. For that matter, if say we try writing the value of root 2, then it is 1.414, and if you try to find it out, you will find that that will come to be a non-repeating and a non-terminating decimal. That means this is not going to terminate, and all the numbers which will come one after another will not follow any format. It will be haphazard, and you will not be able to get the same order of numbers again. So a non-terminating and a non-repeating decimal is actually an irrational number, right? This is what you studied earlier, and here I gave you a new perspective about how you write it in the exponential form. Now children, after this I will give you another concept, that is, if say we have a number say 4, and say in the denominator we have something like root 3 minus root 2, right? And now if say we want to write this as a proper number. Now this is not a proper number, because if we have an irrational number in the denominator, the number is not considered to be a proper number. That means that form is not considered to be standard. Now, to get it in a form such that there is no irrational number in the denominator, in the next step what we have to do is we will be multiplying this by root 3 plus root 2 and again by root 3 plus root 2. Now children, if you watch carefully, we had something like a minus b, and then we called in the conjugate of this, and the conjugate of this is actually a plus b, right? So here thus, if you multiply a fraction's denominator with its conjugate, if it's an irrational number which is a binomial, in the numerator and in the denominator, so obviously what will happen is both of these are going to cancel each other and the old fraction will be back. However, you will be able to derive an advantage out of this. Let's see how. This is then going to become equal to 4 times of root 3 plus root 2, and in the denominator we have something like a minus b times of a plus b, and here quickly be reminded that if you have something like a minus b which gets multiplied with a plus b, I'm sure you studied this in algebraic identities, that this is a square minus b square. So as such, this is also going to become equal to a square minus b square, and here in the denominator we will have this to be a square, that is root 3 square, minus b square, that is minus root 2 square, right? So for the children, this is going to become in the next step as 4, which is divided by root 3 square, which will become equal to 3, and minus root 2 square, which will become equal to 2. And in the numerator we have 4 multiplied with root 3 plus root 2. So here children, this then becomes equal to 4 times of root 3 plus root 2, but the denominator becomes a integer, that is, it then becomes equal to what? It then becomes equal to a number just like 1, right? So here thus, if we write this, then the denominator actually is just 1, and this is a proper number as the denominator is not an irrational number. So finally this number is going to become equal to 4 times of root 3 plus root 2, and children, this should be the answer to this if you're doing this to be done to get to a final answer. Now children, I'll just quickly discuss this again. Remember, if the denominator is a binomial irrational number, then you multiply by its conjugates in the numerator and in the denominator. In doing so, it will not bring a difference because obviously both of these will get cancelled, and as such the old fraction will be back. However, we will be drawing an advantage out of this because we know that if we have some a minus b which gets multiplied with something like a plus b, then it becomes equal to a square minus b square. As such, where we had roots, now we'll be able to square it, and as such here in this case we will be able to write this as root 3 square minus root 2 square, and thus this will actually become equal to 3 minus 2, which then will become equal to 1, which then is going to become equal to a number which is an integer. And now that it is an integer, there is no problem. As such, 4 times of root 3 plus root 2 will be a perfect answer. So this method of removing the binomial irrational number from the denominator is known as rationalization. Okay, so children, now using all of these concepts, right, all that you've learned, we are going to study this now for this complicated question. Now initially I will give you people a little time for trial. You can pause the lecture, take a bigger try, and first do the sum all on your own. If you can't, or even if you've done, then look up the solution of the sum, and then I expect you people to do the sum once more. Now children, here there is one more thing that I have provided you people so that you have a very good idea about this and you're really helped in irrational numbers. That is, I will be providing you people a question which will be there in the description. You will be expected to go to that link, do the question, right, click pics of it, how you've done it, right, and then you will be emailing it to the email ID that I have, that is themathematicshelpline@gmail.com, and then I will be personally checking how you've done the sum, right? And if you are able to do up to this step, you can rest assured that if questions of this sort come, then you will tackle them with ease. Okay, children, so now let's get to the question. So this is the question, children, and initially I'll give you people a little time for trial. I'm sure you people are not enjoying yourselves too much in this environment of this beautiful Nepalese mountain that we have, which is in one of the ranges of Mount Everest. Okay, so get back to the sum. Do try it sincerely, and if suppose you have done it or probably haven't, look up the solution cautiously. I will also give you a second explanation so that everything is clear. And after that, I expect you people to do the sum once more. Okay, children, so here we have x, which is equal to root 5 minus 2, and in the denominator we have root 5 plus 2. So as you know that in the denominator you have an irrational number which is binomial, right? So what you require to do is you require to multiply with the conjugates of the denominator. So thus this is going to be multiplied with root 5 minus 2, and in the denominator also we will have root 5 minus 2. And as we have both of these to be the same entities, they obviously will get cancelled, and that will not bring a change in the value of x. However, to draw an advantage here, we will have root 5 minus 2 whole square, as this has come twice and is in multiplication. And now if you talk about the denominator, we will then have something like a plus b times of a minus b, and we already know that that is going to become equal to a square minus b square. So children, to further simplify this, this then becomes equal to root 5 minus 2 whole square, and the denominator becomes equal to root 5 square, that is 5, and 2 square, that is 4. So from 5 we subtract 4 to make it 1. Now children, to expand the numerator, it is a whole square of the difference of two numbers. So obviously that will become equal to a square plus b square minus 2ab. So as such here we will have this to be root 5 square, right, plus we will have minus 2 square, and then we can write this as 2 times of root 5 times of minus 2, which then becomes equal to 5 plus 4 and minus 4 root 5. 5 plus 4 is 9, and thus this becomes equal to 9 minus 4 root 5, which thus becomes just the value of x. Now remember children, we have to find out the value of x square plus y square plus xy. So after getting to this, we also require to find out what x square is. So now to find out the value of x square, obviously this is now required to be squared. That means 9 minus 4 root 5 requires to be squared. As such, this is going to become equal to 9 square. Then we will have plus minus 4 root 5 whole square, that is b square, and then the 2ab term, that is 2 times of 9 times of minus 4 root 5. Now further children, when we solve this, this will become 9 square, that is 81, right, and then minus minus will become equal to plus because there's a square. 4 fours is 16, and 16 into 5 as this is going to become, because root 5 into root 5 will be 5, so 16 into 5 will become equal to 80. So to this is going to be added 80, and now here further we have 2 which is getting multiplied with 9, and further this is also getting multiplied by 4. As such, 9 fours is 36, 36 into 2 is 72, so this becomes equal to minus 72 root 5, right? So this thus is the value of x square. Similarly children, we also have to find out the value of y square, and here you see that the value of y is actually root of 5 plus 2, right, upon root 5 minus 2. So we will write this value, that is, we now have our y to be equal to root 5 plus 2, and in the denominator we have root 5 minus 2, right? Quickly checking whether this is correct or not. Okay, so now children, if we are to solve this further, what we have to do is we require to multiply it by its conjugates. As such, here this is further going to be multiplied by the conjugates of the denominator, that is root 5 plus 2, right, and the same in the denominator, that is root 5 plus 2. Obviously, both of these being identical, they will get cancelled and not bring any change in the fraction. Now children, here further we will draw an advantage out of this, that is we will now have here in the denominator something like a plus b times of a minus b. As such, this is going to become equal to root 5 square minus 2 square, and the numerator will become equal to root 5 plus 2 whole square. So if we talk about the numerator, that will become equal to root 5 square, which is 5, right, plus 2 square, which will be 4, plus the 2ab term, that is 2 into 2 is 4 into root 5, right. So this will become the numerator, and in the denominator we will have root 5 square, which will become equal to 5, and 2 square, which will become equal to 4, and as 5 minus 4 is 1, so as such here this will give us just 1 in the denominator, which we need not write as 1 is multiplicative identity. So as such, we will now have here 9 plus 4 root 5, right, which is now the value of y. Now remember children, we also require to get to the value of y square. So as such, now if we talk about the value of y square, that then is going to become equal to 9 plus 4 root 5 whole square. That is the last value of y that we found out. We just have to square it, and here too we are going to apply the formula of a plus b whole square, which is a square plus b square plus 2ab. As such, this is going to become equal to 9 square plus 4 root 5 square plus 2 times of 9 times of 4 root 5. So children, this is going to become equal 9 square, which is 81, to which is going to be added 4 square, which is 16, and root 5 to root 5 will become equal to 5. 16 to 5 is 80, so plus 80, right. And then further here we have 9 4 is 36, 36 2 is 72, so plus 72 root 5. So children, this can then be written as 161 plus 72 root 5, which is the value of y square. Similarly children, we also had the value of x square. So obviously 81 plus 80 will make it 161, and minus 72 root 5 was its value. Now remember children, we also require the value of xy, right. So next, now when we talk about the value of x into y, that is actually the product of x and y, we have the value of x to be root 5 minus 2 upon root 5 plus 2. So root 5 minus 2 divided by root 5 plus 2, and we just had the value of y, which is root 5 plus 2 upon root 5 minus 2. So into root 5 plus 2 divided by root 5 minus 2. Now children, here we get to see that there are terms which are identical and which will easily get cancelled as they are in multiplication. So obviously root 5 plus 2 will get cancelled with root 5 plus 2, and root 5 minus 2 will get cancelled with root 5 minus 2. As such, you will get to 1, which will be the value of xy. Now remember children, we have to find out the value of the expression, which is x square plus y square plus xy. So we can further find this out by just keeping the values that we've already found out and adding them up. So x square was what? 161 minus 72 root 5. So 161 minus 72 root 5, to which is going to be added the value of y square, which we got to be 161 plus 72 root 5. So plus 161 plus 72 root 5, and to that is going to be added xy, which is 1. So here children, we find that these two terms being additive inverse of each other will get cancelled, as both are identical. One is 72 root 5 and the other is also 72 root 5. One has a minus sign and the other has a plus sign, so obviously they will just get cancelled, just like 2 and minus 2 get cancelled. Now next, what you do is you will add these three terms, that is 1 with 161 with 161. So 1 plus 1 is 2, 2 plus 1 is 3, then we have 6 plus 6 is 12, one remainder. Then we have 1 and 1 is 2 and 1 3, so 323 will become the final answer. That is what we were required to do. Of this complicated question, we were required to get to a simple answer. Okay children, so all of this that I discussed, I will quickly discuss with you, so that if you have any doubt in any step, all of that will now get removed. Now children, in the question you've been given here, x is equal to root 5 minus 2 divided by root 5 plus 2. And you've been given the value of y to be root 5 plus 2 divided by root 5 minus 2. And you have to find out the value of x square plus y square plus xy. So in a question like this, when you get to see that in the denominator you have a binomial irrational number, what you require to do is you require to multiply with the conjugates of the denominator in the numerator and in the denominator. There is no problem in doing this, because the same term is in the numerator, the same term is in the denominator. Both will get cancelled. As such, the old fraction will come back. But we are going to draw an advantage. That is why we did this step. So in the denominator, you have something like a plus b times of a minus b. And I'm sure you people remember that if you talk about a plus b, which gets multiplied with a minus b, right, we have it to be a square minus b square by algebraic identities. As such, here too, we have it to be root 5 square minus 2 square. So root 5 square will become equal to 5, right? And 2 square will become equal to 4. So as 5 minus 4 is 1, 1 is multiplicative identity, you need not write it. Now, we talk about the numerator, which is root 5 minus 2 whole square. So obviously, this is just like a minus b whole square. So it will be a square plus b square minus 2ab. So that is root 5 square plus minus 2 square, that becomes equal to 4, right? And the 2ab term, which is 2 times of root 5 times of minus 2, which will become equal to minus 4 root 5. Now as root 5 square is 5, 5 plus 4 will be 9, and this will give you 9 minus 4 root 5. Now children, remember, this is just the value of x, right? As you require the value of x square, so you further require to square this. So next, now what's going to happen is you will just write a minus b whole square, just like you did above. So this will become 9 square, right, plus minus 4 root 5 whole square, and plus the 2ab term, that is 2 times of 9 times of minus 4 root 5. So for the children, 9 square is 81, and minus minus will become equal to plus. 4 square is 16, and root 5 square will become equal to 5. 16 to 5 is 80, so as such this will be plus 80, and then you will have plus into minus, which is minus, right? Then we have 9 4 36 to 72, so this will be minus 72 root 5, right? Now adding up the like terms, you will have 161 minus 72 root 5, which will be the value of x square. Now next children, we require to find out the value of y square, which is root 5 plus 2 divided by root 5 minus 2. And again here, as we see that in the denominator we have a binomial irrational number. That means this expression, which has at least one of the terms to be irrational, has actually 2 terms, so it becomes a binomial. In such a sort of a case, what you do is, to simplify, you will multiply with the conjugates of the denominator. Now the conjugate of the denominator is going to become equal to root 5 plus 2. As such, with that we multiply in the numerator and in the denominator. This way of simplification is known as rationalization. Now next year, children, what we do is we then talk about a minus b times of a plus b, which we know becomes equal to a square minus b square. As such, the denominator becomes root 5 square minus 2 square, that is 5 minus 4, that is just 1, so we need not write it. Now if we talk about the numerator, it is again a plus b whole square. So that will become equal to a square plus b square plus 2ab. As such, it becomes equal to root 5 square, that is 5, plus 2 square, which is 4, plus the 2ab term, which is 2 times the root 5 times of 2, so that will be plus 4 root 5. Now children, 5 plus 4 is 9. As such, this becomes equal to 9 plus 4 root 5. Remember, this is just the value of y. Now as we require y square, we further have to square this. So that then becomes equal to a square plus b square plus the 2ab term. So 9 square is 81, and 4 root 5 square will become equal to 4 square is 16, and root 5 square is 5. 16 5 is 80. Then we have this 2ab term, 9 4s is 36, 36 2s is 72, multiplied with root 5 will become equal to 72 root 5. 81 plus 80 being like terms can be added, which will become 161 plus 72 root 5 will become the value of y square. Now children, we have the value of x square, we have the value of y square, we just require to find out the value of xy, right? As that is the third term which is to be added to the sum of these two that we've already found out. So if we talk about xy, we see that x and y are actually inverse of each other, as the first is root 5 minus 2 and the denominator is root 5 plus 2, and the second is root 5 plus 2 divided by root 5 minus 2. So we find that both of these terms from the numerator and from the denominator, being identical terms and also in multiplication, will get cancelled. Similarly, we will have these terms also getting cancelled as they are identical and in multiplication. So the value of xy will come to 1. Now as you require the sum of all of these three, that is x square plus y square plus xy, so we keep the values of these three and just add them up. So the first, if you remember, is 161 minus 72 root 5, and that we are going to write here, right? And further, if we talk about the second one, that is 161 plus 72 root 5, and to that is going to be added 1, which is the value of xy. So here children, minus 72 root 5 will get cancelled with 72 root 5, as both of these are identical but they are additive inverse of each other, just like minus 3 plus 3 will get cancelled. Now to add 161 and 161, we will have in the units place 1 plus 1 plus 1, which will give us 3. Then in the tens place we will have 6 plus 6, which is 12, 1 remainder. And then in the hundreds place we'll have 1 plus 1, 2, and 1 remainder, that is 3. So 323 will become the final answer. And children, this is how we did the complicated question, which is one of the most wanted questions for your examination, such that we got to a simple answer. So I'm sure children that you have all understood this and will surely practice this just now, once more, just now. Right? And after that children, there is another question which you will find in the description. Make sure you do that question also, right? And after doing that question, you click pics of it and do send it to my email ID, which is themathematicshelpline@gmail.com. This is how I aspire to help you people, and make sure you take the help in the proper way and make your journey to perfection in mathematics really soon. So children, bye, have a nice time, and do enjoy your day, but make sure you do the proper practice in maths. Bye.